Okay, I want to make this blue sprite to bounce off the edges of this canvas, and I'm going to create a new class for that. Let's call this one ball.js. So sort of the logic I'm going for is that a block is just an object on a canvas, a sprite is a block that moves, and a ball is a sprite that bounces. And obviously we don't really need all of these abstractions. I'm somewhat shoehorning them into this problem domain. The application we're building is simpler than it would require all of these classes that I'm making. So take that with a grain of salt. The purpose is just to show you how you would make a type hierarchy. So let's go here and again implement the idea that I have. So let's say class ball extends a sprite. And so I misspelled extends. And if we want to use a sprite, we got to import it. So import a sprite from a sprite.js. And then if we're going to use ball in other places, we got to go and export default ball. Okay, cool. So again, a sprite, a ball is a sprite that bounces. So that's the behavior that it adds. And what we need is to give it the constructor. So let's give it a constructor, and for now we're going to just keep all of these variables, and then we think about if we need more. So far all of these we can just call the constructor of a sprite using super. So I can put the dx and dy here as well and take this out. Okay, and now let's think about how we want to implement the bouncing behavior. So we basically have like 4 edges, right? So we can say bounce off the left edge, and then bounce off the right edge, and bounce off the top edge, and bounce off the bottom edge. Okay, so we got to find a way of recognizing that we hit or reach the left edge. So we can do that in a few different ways. Here's one idea. If we think about, like, let's focus on this bigger red ball. If we kind of move it to the left when it hits this edge, it's at a point where, like, if you think about its xy coordinate of its top left, its x coordinate is going to be 0. Like anywhere on this edge, its y is going to be different values, but its x is going to be 0. So if we say, here's the condition, if x is 0, well, this dot x. If it's 0, or you know, depending on like its dx, it might actually like pass that point. So if this x is less than 0, so if it got to that point or it passed that point, then we know we sort of hit the left edge, right? So that's the idea. And we can sort of reason in a very similar fashion about reaching the top, because when you reach the top, the y coordinate at the very top, the y is 0, but x changes. So we can say if this dot y is less than 0, okay, then we want to bounce off. Now we got to think about how do we know if we reached or passed the right edge, right? So if you think about the right edge, so what happens in the right edge? Well, we kind of like move, and so moving towards the right, it means that our x is getting larger and larger and larger until it gets to a point that like we reach the width of the canvas, right? We reach the width of the canvas. So maybe what we can do is we can like, we need to get the width of a canvas. We can maybe pass the canvas argument, like that object, we can pass it here, and then comes here, maybe we can like say else if this dot x is greater than canvas dot width. So then that would be like bouncing off the right edge. Now we kind of need to think about what are our options. Does it make sense if we provide this as a constructor rather than as an argument to bounce? I want to argue that it doesn't make sense. This is a better design because canvas is not a property of ball, right? So these information are all attributes of the ball. They define the state of the ball, but the canvas is like independent from the ball. It's just that for the bounce function, we need that information. So I think it's right that we provide that as an argument here rather than as part of the constructor. Now, another thing I want to think about and entertain the idea is that do we need to pass like the entire canvas object, which has a lot of different functions and attributes, including width and height? Well, it's a reference variable. It's not like we're copying all of that information. However, here's an argument in favor of being more specific. If somebody just reads this function and they look at the argument, maybe the code here is short enough that they can understand that. But if the code was longer or the logic was more convoluted, more complex, it's not going to help to see just the canvas. They wouldn't know, a reader will not know what is it that you need off the canvas. So that might be an argument for being more intentional and say like, actually what I need is just the width and the height, right? So like exactly define just what you need. Why am I keep misspelling it? Exactly define what exactly you need, and an argument can be made that this is a better way of writing functions. So else if so this y is greater than the canvas height. So if the y coordinate reaches like the height of the canvas and it gets like past that, or it reaches that, then it means you sort of hit the bottom edge, right? And it can happen like here, at any point. You could be anywhere. So your x doesn't matter. It's just that your y matters, and you want to check it against the height of the canvas. So that's the bounce of the bottom edge. Okay, so we're getting somewhere. Let's see what else we can do. Now, how can we bounce off any of these edges? Well, if you think about it, like if I'm sort of like, if this object goes backward, right, it goes to the left, then what that means is that its delta x is a value. It's like a negative value because it keeps making its x smaller. So if I wanted to hit here and kind of bounce off and go to the other direction, then I need to make the delta x of it to add to the x of this value rather than subtracting from it. So in other words, I need to flip the sign of it, right? Like if it's negative, which is probably what it is, that's why it's bringing it backward, right? If it's negative, I need to make it positive. So I can go and say this dot x and just multiply that by -1. What that does is that it basically reverses the horizontal direction. And actually, something very similar to that needs to happen for when we travel to the other direction. So if we are going to the right edge, then our x is keep being incremented, right? So delta x must be a positive value. If we want to bounce off, we need to go to the opposite direction. So we need to flip the sign of delta x to make it go to the opposite direction. So effectively, it's like the same thing we need to do in here. And it's very similar idea when it comes to bouncing off the top and the bottom. You just have to do it with the, well, sorry, what I meant was delta x and delta y, right? Because that's what defines, not the x and y, the delta. If you just flip the x, you're gonna like go to the other side of the coordinate system. So the delta y, like if I'm here and I'm going towards the bottom, it means that my y is increasing. It means that my delta y is a positive value, and it keeps adding, because I'm keep adding delta y to it, and it keeps adding and it keeps going down and down. So when it hits the bottom at this point, if you flip the sign of the delta y, it means that now at every game loop, you're going to be decrementing the y, and it's going to come up and go to the other direction until it reaches the top, and then you reverse it again. So that's why we have this logic here. Okay, so let's go give this a try and see what it does. We can go back to main.js. Let's change this. Instead of a sprite, we just make this a ball. So this is a ball, and we need to instantiate a ball class, right? And let's come here and say ball, and then do the bounce as well. And so when we do the bounce, we need to give it the canvas width and canvas height. Okay, let's clean this up a little bit more. Let's get rid of this red block. We don't really need it. We got a ball. Here are its properties. We instantiate it, and then we come here and we're like, okay, so draw the ball, move it, and then bounce it if it hit the any of the edges of the canvas. So let's save this and take a look at our code. And there you go. We've got ourselves a ball that moves, and then when it hits any of these edges, it bounces off.